Hey everyone, welcome back to Circuits and Sprockets. Today I'm working on this Cuisinart rice cooker / steamer. And as far as kitchen appliances go, this thing is just about as simple as it gets. Basically, you just put the correct ratio of rice and water in, and then turn it on. And when all that water has been absorbed by the rice, it will turn itself off. And so really, this thing really only does two things, right? Warm and cook. So when you plug it in, it'll automatically light that warm light. You put the rice and the water in, and then you flip it down, it'll flip over to cook. And when the rice is done, it'll automatically turn itself back over to warm. So this thing really only has two states, the warm and the cook. And when you plug it in, like I said, it will automatically go to warm. Now, my problem is when I plug it in now, it doesn't do anything at all. So that warm light is still off. It is indeed not getting warm. And so I'm assuming there's some kind of issue with the wiring inside. So I thought I'd dig into this a little bit, see if we can't learn a few more details about how this thing works, and see if we can't get this thing operating again. So I'm going to dig into it here. And to start with, there's just two screws on the bottom to get access to the inside. So I'll undo these screws, open this bottom cover, and see what we can find out. Okay, so it looks like the power, of course, is coming in through these wires here. And it looks like it goes from that power cord through this switch to two different heater circuits, it looks like. And I think that would make sense, right? So I'm assuming the warm circuit has one kind of low power heater, and then the cook circuit has a different heater that's a much higher power. And then I think, so this switch here, first of all, it's controlled by the lever that I showed at the beginning. So you can see, if you look right here, when I actuate the lever, you can see that little silver tab is going up and down, and you can hear the switch clicking. So I think power comes in here, and then depending on the state of this switch determines whether it goes to the cook heater or the warm heater. Okay, so just want to dive into the wiring of this switch a little bit more, maybe a little bit clearer explanation. So the wire's coming in at the top from the plug. The black wire that you see is the hot 120 volts, and the blue wire is the neutral. And so you've got power coming in on this black wire. It goes through, I'm not sure what this is, but it goes through here. It comes out as a white wire. It comes into this little crimp connector here, and it comes out and goes to this top terminal. So this terminal here is where I would expect to see 120 volts. And then, you know, if my kind of theory is correct, that means the other two terminals that you see on the switch here and here at the bottom are the two heater circuits, one for warm and one for cook. And so I just want to kind of confirm that, right? And so I've got my multimeter here, and I'll set it to continuity. And so if I touch any 2 points in here that are connected, you'll hear a beep like that. And you'll see the meter show whatever the resistance is. And so if I put one lead here where the power comes in, and I know that the switch here, the toggle switch, is in the warm position, then one of these two terminals should beep, and that would be the warm circuit. Okay, so it's not the bottom one. Okay, and you hear the beep on that middle terminal. And so that is the warm circuit. And then if I hold the switch closed, then we should hear a beep on the other terminal. And we do. And so if I hold it here and then let go of the switch to put it back into warm, that beep should go away. So I'll hold it onto the cook circuit and release the switch, and you do hear it disconnect there. So okay, so I think we've got a good understanding on how that three-way switch works. So let's dive into those two heater circuits a little bit more. So let's start with the warm circuit. If I follow the wiring for the warm circuit, it's got a white wire coming out of the terminal here. It comes around this loop through this plate marked 400. And I'm not sure what that is trying to tell me, if that's 400 ohms or 400 watts. Yeah, I'm not really sure, but I'm sure this is the warm circuit heater. And then the other wire comes out, back around, and it's connected to a terminal block here that's connected to the blue wire, which, if you remember, is the neutral wire going back to the wall. So that's about as simple as it gets. It's just taking the 120 volts from the incoming circuit, sending it to this heater, and then going back out to the wall. So if we look at the cook circuit, let's see, I'm looking at the wire here at the bottom. That's a black wire coming out here and looping to this terminal here. Let's see if we can get a better look. And it looks like there's another heater underneath here that I'm assuming, just based on the shape of it, probably circles all the way around and comes out here. And then this plate is connected again back to that blue wire, which is the neutral that goes back to the wall. Okay, so maybe a couple of things we can learn here. If I turn the meter back over just to resistance, we can measure the resistance of those two heater circuits. Now I would think, let me think, the resistance of the warm circuit should be much higher than the resistance of the cook circuit. The reason I say that is, a lower resistance will produce more heat, and so in order to get more heat for the cook circuit, I would expect to see a much lower resistance reading in terms of ohms. Okay, so let's put that to the test. So I've got the meter set to resistance, and if I put one probe on where the power goes into the warm circuit, and then the other probe just anywhere on the neutral that goes back to the wall. Okay, I'm seeing 0.588 kiloohms, or 588 ohms. Okay, so we'll keep that number in mind. We'll keep this probe on the neutral, and then we'll put this probe on the cook circuit. And so now we're reading the resistance of that cook heater. Okay, and we are seeing 33.3 ohms. So yeah, okay, so that kind of confirms what I would expect to see. We see a much lower resistance on what I think is the cook circuit, and this kind of confirms that, that 33 ohms compared to 588. Okay, so that doesn't help us troubleshoot the problem too much, but it does give us a better understanding of how this thing works. So like I said, I mean, it really is dead simple. There's just the one switch here that toggles between the warm circuit and the cook circuit. You know, the warm circuit having that higher resistance heater, and the cook circuit having that much lower resistance heater, which it enables it to produce much more heat. So let's see. So the symptom that we know we see is that warm LED doesn't light up. And so that means that when I plug it in, that 120 volts is not getting here to that warm circuit at all. And so that, let's see, that could mean two things, right? One is that 120 volts isn't it's getting broken somewhere on the wiring on the way to the switch itself. So we're not even getting 120 volts here. Or it could mean that the switch itself has failed, and it's not, we are getting 120 volts here, but the switch isn't enabling 120 volts to get here. So how do we test that? Okay, so I think what I'll do is I'll plug it back in. Of course, I want to be extremely careful once this thing is plugged in, but I'll measure voltage from here over to the neutral, and we'll just see if we get 120 volts. If we do, then we'll zero in on the switch, and if we don't, then we'll zero in on the wiring coming over to that switch. So let me get the camera set up a little bit safer, so I have full access to everything I need, and I'll bring you back in a second and I'll get this thing plugged in. All right, so we will set the meter to measure AC voltage, and we will plug the unit in. And so like I said, this now has 120 volts somewhere in there, although that's kind of the problem we're after, but we'll want to be extremely careful now that this thing is plugged in, especially since we don't know where voltage is and where it isn't. So like I said, our goal here is to determine if our missing voltage is concerned with the wiring coming to the switch, or is it with the switch itself. And so I'll put one probe on the terminal where we know voltage should be. This is the power coming in from the wall. And then the other probe we'll put on the neutral. And if we see 120 volts here, then we'll dig into the switch a little bit more. And if we don't, then we'll dig into the wiring a little bit more. So we'll get the probe over here on the neutral. Yeah, and there's no voltage at all. So voltage isn't even getting to the switch itself. So now I'm not concerned with the heater circuits at all. I think those are probably fine, although we'll find out once we solve this voltage problem. But so now we know that voltage isn't even getting here. So what else can we test while this thing is plugged in? Okay, so we know that voltage is coming in, assuming the outlet that I'm plugged into works, and I know it does. We know we should have 120 volts on this wire here. This is coming straight from the plug itself. So let me shove one of my probes in here and put the other one, get out of the way so you can see the meter, put the other one on the neutral. Okay, and we see 122 volts AC. Okay, so we know that we have voltage to this terminal here. Let's see, just following the wiring, it goes through this device. It comes out this wire. Okay, let's put a probe in this connection as well. And put this on the neutral. Okay, and we don't see voltage there. Okay, that's interesting. Okay, so I'm going to unplug this while I think about it a little bit. So we know we have voltage at least this far, and there's a breakdown somewhere in the wiring before it gets to this this crimp connector here. And really the only thing between these two connectors is this thing that I've said a couple of times. I'm not sure what it is. Okay, well, there's a screw here that's holding this device to the casing itself. So I'm going to see if I can open this up a little bit more. I might have to cut some wire ties, but open this up a little bit more and see if there's, some disconnected wiring in there or something. So let's dig in a little bit further. Okay, so yep, maybe I should have suspected this, but so that device that I said I wasn't sure what it is a fuse. This is a thermal fuse, and I'll have to decipher the ratings on there, but I'm willing to bet that this thing has blown, and so voltage is coming in just fine, but this is now open, and so there's no voltage going to the rest of the circuit on this side. So you know what, I'm going to confirm that with the meter, so I'm going to put this back. I'll set the meter to AC volts again. And I will plug the unit back in. Okay, and I'll put, let's see, I'll put one lead on that neutral where it was before. Get my hands out of the way here. And then I will test the incoming side of this fuse, and I expect to see good voltage here. And we do see 122 volts. And then on the other side of this fuse, I expect to see nothing. And then that is what we see. Okay, so that confirms that this fuse is blown. So I do have some thermal fuses in the stash, but I'll have to decipher the, I have to make sure that whatever I put in there is rated the same way as that device that you see there. So I'll have to decipher the ratings and things. I'll see what I have. And if I have it, then we'll just, we'll get that thing replaced. All right, so diving into these markings a little bit, you can see the fuse number is SF188E. It's rated for 192 degrees C, 10 amps, and 250 volts. And unfortunately, the only ones I have right now are rated for 115 degrees C and 2 amps. So drastically different rating there, and I definitely don't want to put that in. It's definitely best practice to put the same rating fuse back in, especially if you're not sure why it's blowing, which is something I'll have to maybe dive into a little bit more. But anyway, these are pretty readily available online, and so I'll you can just get an order placed for a replacement one of these, and I'll bring you guys back when that comes in. All right, so it's a few days later, and the fuses that I ordered came in. You can see it's the same SF188E. 10 amps, 250 volts, and I think most importantly, 192 degrees C. This was a 5-pack, so I only need one, right? So I've got a few spares, which is good. And then it also came with these crimp connectors too, which will be useful. I'll basically just shove the fuse terminal in one end and the wire in the other end and crimp that down. That'll be a nice solid connection, I think. So the next step here is going to be to cut out this bad fuse. So I'll just trim off the wire, just trim off just a tiny little bit of the wire where it's crimped on here. I'll get the new crimp connectors in, and get the new fuse in, and get everything crimped down, and we'll give it a test. And now the fuse is cut out, I'll strip back just a little bit of this insulation to expose the bare wire that I can put into that connector. Okay, that looks pretty good. We'll do the other wire. Get this sheath out of the way. Remind me to put that back on before I put this back together. Okay, so I've got the fuse cut out, I've got these wires exposed. I think what I'll do first is put those connectors on the bare wire, and then I'll put the fuse on. Okay, so I've got the wires, I've got the connectors crimped onto those wires. So now I'm going to put the fuse back in. Now, I can't imagine why polarity would matter on this, and what I mean by that is, should it go in this way or this way? And I don't think it matters, but the old one was in with this black part facing the outlet, the wires coming in, and so I'm just going to put it in the same way. Like I said, I don't think it matters, but I might as well follow what was in there. Oh, almost forgot. Thanks for the reminder. Yeah, I wasn't crazy about the strength of that with just the small pliers. These channel locks are working much better, so I'm going to have to get a better connection there. I'm actually gonna, let's see, I'm gonna trim this sleeve down a little bit just because it's kind of difficult to work on this. Just a very little bit. Should help. That's much better. All right, so those crimp connections are pretty good, but I'm not thrilled about them. I don't think they're as strong as they could be. So I'm actually going to just drop a little, I'm going to just dab a little, I'm going to do a little solder connection on each of these just to make sure that everything is solid before I put it all back together. All right, so that wasn't my proudest soldering job, but I definitely got lazy there and just kind of globbed it on. But really, I'm just looking for, I think the electrical connection was fine, but I was looking for some mechanical strength, which I know you're not supposed to use solder for, but I think this is going to be fine. So I'm going to slide this sleeve. Actually, before I put that sleeve back on, in theory, this thing should be working now that that fuse has been replaced. So let's see. Before I plug it in, though, let's test it with the meter. So let's see. Let's put the meter into continuity mode and test that. Okay. And so before, when this fuse was open, if you touched, you know, the input and output, I guess, of the fuse, it was not connected. So we were not getting a beep across that fuse. And now, if I put a probe on the output side and a probe on the input side, we should hear it beep. And we do. So that's great. And so let's see, the true test, I guess, is if I plug this in now, we should see that warm light come on. So let's try that. Also, the warm heater will come on too, but of course, we won't be able to see that. Let me prop this up a little bit. And if I plug this in, we should see that warm light come on. So I'll plug this in 3, 2, 1. Yep. And we see that warm yellow LED come on. Let me kill my light so you can really see it. So you can clearly see that warm light is on. And if I press the lever down, we should see it switch over to cook. And we do. Okay. So I think this thing is back to working normally. So I'm going to unplug it and we'll get this, get everything kind of closed back up, and we'll make sure it's working after everything is closed up as well. So with trimming these wires back a little bit and also trimming the sleeve a little bit, well, I'm seeing, so we've got exposed connections on both sides here. And so obviously, the cover will be on and everything, but just to be absolutely certain that, that those don't make connection, or make contact with anything they shouldn't, I'm going to throw a little bit of electrical tape over each of those 2 connections. Okay, again, it's not pretty, but it doesn't need to be. All right, so we'll get this thing back into its holder here. And I think I kind of breezed over this during disassembly, but I didn't actually need to take this whole bracket off. It was held, that fuse was held to this bracket with this, well, I don't know, for lack of a better term, holder. And you just kind of slide it in there and then fold the tabs up and it holds it securely in there. Okay, that's looking pretty good. So now everything is reconnected electrically and mechanically underneath here. So I think we are ready to get that bottom cover back on. All right, we are fully back together and operational. So this one was pretty straightforward. You know, there was nothing wrong with the control circuitry of the unit. That switch was working fine. The heaters, I think, are working fine. It was just that thermal fuse that had blown and disconnected power to the entire unit. Now, I touched on this earlier, but I do want to say, you know, I don't know why that thermal fuse blew. And that's something that really should be figured out as a full troubleshooting activity. So that's something that I'll definitely have to keep an eye on, right? If this new fuse blows, then, you know, I'll have to dig into the unit a little bit more. That, you know, that may mean there actually is something wrong with one or both of the heaters that's causing this thing to draw too much current and blow that fuse. And if, yeah, honestly, if I have to dig into it further, you'll probably see it on a future Circuits and Sprockets video. But for now, I think we'll just put this thing back in use. And we'll obviously be keeping an eye on it. If it doesn't turn on when it's plugged in one day, we'll have a pretty good idea why. So I want to thank you for taking the time to watch the video. If you liked the video or if you learned anything from it, please consider leaving a like. If you want to see more videos like this, I'm putting out a bunch of repair videos on, like, you know, small appliances, electronics, small engines and things like that. If you want to see more content like that, please consider subscribing. And with that, I'll see you guys in the next one.